and good evening everyone.
This is topic 1, number system and equations.
Will be represented by Liang Longjun, J. Marcus Govin, Fatina Bila Bint Abdurrahman, and Pang Jahui.
In this topic, we will learn about two main subtopics. The first one is real number, the second is indices, sets, and logarithms. In real number, there are two parts. In indices, sets, and logarithms, there are three parts. In real number, in the first part, you will learn about natural number, prime number, integers, whole number, rational, and irrational number. On the second part, you will learn about number line. In the number line, you will learn about intersection and union operations on intervals. On the second subtopic, indices, sets, and logarithm, you will learn about rules of indices, algebraic operations on sets, and law of logarithms.
Now let's go to the first one, natural number. Natural numbers are positive numbers. They are used for counting and denoted as capital N. They start from 1, 2, 3, 4, and so on. Note that natural numbers include prime number and non-prime numbers. So what is prime numbers? It's the natural numbers that are greater than 1 and can only be divided by itself and 1. For example, 2, 3, 5, 7, and so on. Now for the next one, we have whole number. Whole numbers, basically the natural numbers together with the 0 and denoted with capital W. For example, 0, 1, 2, 3, and so on. Next, we have integers. Integers is the whole numbers together with the negative of counting numbers and denoted by Z. For example, start from negative 2, negative 1, 0, 1, 2, 3, and so on. Next, we have rational numbers. A rational number is any number that can be represented as a ratio of two integers and denoted as cube. For example, 1 over 9 is equal to 0.111 and 3 over 11 is equal to 0.272727. Now note that natural numbers is a subset of whole number. Whole number is a subset of integers and integers is a subset of rational numbers. In general form, we can have rational numbers in the form of A over B, where A and B can be any element of Z, but B cannot be 0. Next, the irrational number can be written as a quotient and non-repeating decimal. For example, sub2 is equal to 1.411 and pi is equal to 3.12159. Now note that rational numbers union irrational numbers is equal to real number. Now let's say example 1. Let's set n equal to negative 12, negative 9, negative 0.8, 0, sub 4, sub 12, 8, and 58 over 6. List the elements from n that belong to each of the following sets. For a rational numbers, we have the answers that is negative 12, negative 9, negative 0.8, 0, 8, 58 over 6. For the b irrational numbers, we have the answers that are sub 4 and sub 12. For the integers, we have the answer negative 12, negative 9, 0, and 8. For the whole number, we have 0 and 8. And for the last one, natural numbers, we have the answer for 8.
So, we go to the number line. The number line is the set of numbers that corresponds to all points on number lines is called the set of real number. The real number on the number line are ordered in increasing magnitude from left to the right. This means your right hand side of number line should be the smaller value and your right hand side of the number line should be the bigger value. So let's see the example here. We have negative 2 less than or equal to x less than or equal to 5. So both have dense circle. So this is called cross interval. And when you write in the interval form, it should be cross bracket negative 2 cross bracket 5. So let's see another example here. X less than to 0, we have open circle at 0 to the left hand side because we are going to the negative infinity. So when you write in interval form, the negative infinity should be always open bracket and 0 also open bracket. So we call it open interval. Now we are going to learn intersection and union operations on interval. The intersection of two intervals is the set of the real numbers that belong to both intervals, while the union of the two intervals is the set of real numbers that belong to one or the other or both of two intervals. So let's see the example here. We have a set from negative 4 to 2, union with 0 to 3, and intersection with an interval from close bracket negative 2 open bracket 5. So we have two steps to solve this question. So for the first step here, let's see in the number line, we have negative 4 to 2 open circle and we have 0 to 3 open circle. Now we take the union between these two. Finally, you should get an answer -423 with open bracket. Next, you take this answer intersection with -2 included to 5 excluded. See the number line here. Now, the intersection will be the middle between -2 and 3. So the final answer is -2 is included in both intervals, but 3 is excluded in these intervals. So we cannot take 3 in our final answer. So your final answer should be cross bracket at -2, open bracket at 3.
There are 9 rules of indices. The first one is a power of n times a power of n, we will get a power of n plus m. A power of n divided by a power of n, we will get a power of n minus m. A power of n times a power of m, we will get a power of n times m. If a power of 1, we will get a, and any number that powered by 1, we will get the number again. And a power of 0, you will get 1, and any number that powered by 0, you will get 1. If a be powered by n, if we separate, you will get a power of n, b power of n. If a power of negative n, we have to make it fraction in order to make the power to be positive, so you will get 1 over a power of n. If a over 1 over n, it means a square root of n. If a power of n divided by m, you will get a power of n square root of m. Answer the question. Given that 64 over 27 powered by -2 over 3. Follow the rules of indices. First, we have to know that -2 is the power, and divided by 3 means they are square root 3. So first we have to solve the square root 3. So by following the BODMAS, you will get 4 over 3 power of -2. And then to make the power to be positive, you have to change the position of denominator and numerator. So we get 3 over 4 powered by 2, and then you solve, and then you get 9 over 16.
Next, search. From the slide here, we can see 7 rule of search. Note, search A plus B is equal to search A plus search B. Continue to the number 1. Search A times search A is equal to A. Next, we have A times search B multiplied to A times search B. It is equal to A squared times B. Third, search A times B, it is equal to search A times search B. Same goes to number 4, we make it division. Search A over B, it is equal to search A divide with search B. Number 5, we have A over search B. Since the equation got search in the denominator, it need to be rationalized by multiply to the conjugate itself. A over search B times search B over search B. And the answer is A times search B over B. Next, we have A times search C plus minus B times search C, and it's equal to A plus minus B times search C. This only can be done if you have same value of search, for example, search C. Lastly, we have number 7. A over B plus C times search N. Again, since it got search in the denominator, and need to multiply to the conjugate. To rationalize it, the conjugate is B minus C search N over B minus C search N. It came from the denominator from the equation before, but the middle sign from the denominator need to be changed. So let's go jump to the question of search. Simplify in bracket search 3 minus 2 times search 2. Multiply in bracket search 3 plus search 2. So firstly, you need to expand the equation one by one. Search 3 times search 3 plus search 3 times search 2. Next, minus 2 search 2 times search 3 minus 2 search 2 times search 2. So we have 3 plus search 6 minus 2 times search 6 minus 4. So 3 minus 4 equal to -1, and search 6 minus 2 search 6 equal to -search 6. This is the rule of search that we learned before from number 6. So the final answer is -1 minus search 6. So now we have mean at the end of the subtopic from this topic, logarithm. From the slide, we can see 7 laws of log. First one, we have log m base a plus log n base a, it's equal to log m n base a. This is because it got same base of log here. Next, log m base a minus log n base a, it is equal to log m over n base a. Third one, we got log m to the power of n base a, it's equal to n log m base a. The power of n can be dragged to in front of the log. Number 4, we got log 1 base a, it's equal to 0. Every log 1 base any number, it is equal to 0. Next, log a base a, it's equal to 1. Number 6, a to the power of log x base a, it's equal to x. And lastly, number 7, log x base a, it's equal to log x base b over log a base b. From the example, disperse each of the following as a single logarithm: 3 times log r base b plus m times log t base b minus 5 times log p base b. The solution is, since it got same base of log here, which is log b, all the numbers in front of the log will be moved to the back as the power. So 3 times log r base b will be log r to the power of 3 base b, and m times log t base b turns to log t to the power of m base b, and negative 5 times log p base b equal to negative log p to the power of 5 base b. So now we have same base log b. Lastly, r to the power of 3 plus t to the power of m will be multiplications, and minus p to the power of 5 will be divide. So the answer is log r to the power of 3 times t to the power of m divide with p to the power of 5 base b.